Hello everyone, this is Dr. Chandrika, Professor, Department of EEE from KPR Institute of Engineering and Technology. In today's video, we are going to study the concept and applications of Thevenin's theorem. We are going to learn how to find VTH, RTH and the current flowing through the particular resistor. Now let's get into today's lesson. According to Thevenin's theorem, any linear circuit connected between two terminals can be replaced by a Thevenin's voltage in series with a Thevenin's resistance, so that Thevenin's voltage, that is VTH, is the voltage seen between the two terminals A, B, and the Thevenin's resistance RTH is the equivalent resistance seen between the two terminals when all the independent sources are deactivated. And we also have RL, which is called as the load resistance. This load resistance is in series with RTH, so that the current produced by VTH will be the same current flowing through RTH and then RL, and this RL is also the resistance you want to find the current flowing through. So from this particular circuit, if you want to find the current flowing through the load resistor, then that is given by I equals the voltage divided by the total resistance of the circuit. Now, since these two resistors are connected in series, then RT is equal to the sum of these two. Since we have V in to be VTH, we say I is equal to VTH divided by RTH plus R1. So basically this is how we have to find the current flowing through the load resistor. Now let us see how do we even arrive at the values of VTH and RTH and then RL. To do so, we are going to use the steps outlined below. Given any linear network connected between two terminals, the first thing we need to do is to remove the resistor which we want to find the current flowing through and then mark the terminals. Secondly, we need to find the open circuit voltage, that is VTH, using Kirchhoff's voltage law. And then thirdly, we have to deactivate all the independent sources and find RTH. So while deactivating the independent sources, we are going to short circuit all voltage sources and open circuit all current sources. Next, we are going to produce the Thevenin's equivalent circuit by reconnecting the load resistor. So this is the Thevenin's equivalent circuit with the load resistor reconnected, and then lastly we are going to find the current through this resistor, that is using the formula I equal to VTH divided by RTH plus R1. Basically these are the variable steps we are going to use to find VTH, RTH and the current flowing through the particular resistor. Now let's take a few examples. Let's take this example. First example, find VTH, RTH and the current flowing through the 3 ohm resistor in the circuit given below. So for this circuit, we have two voltage sources, 42 volt and then 35 volt, and then we have 3 resistors connected in the circuit, the 12 ohm, the 3 ohm and there is a 6 ohm. Now we are going to find VTH, RTH and the current flowing through the 3 ohm resistor. To solve this circuit using Thevenin's theorem, the first thing we need to do is to remove the resistor through which we have to find the current flowing through, and then we mark the terminals and then find VTH. Let's do that together. So we have the voltage source, that is 42 volt. We have this resistor to be 12 ohms. We have this one to be 6 ohm, and then we are going to remove the 3 ohm resistor and we are going to mark the terminals as A and B. We have the 35 volt source and then we complete the circuit. So we call this as VTH, that is the open circuit voltage seen between the two terminals. At this point, we are going to distribute current in the circuit, and then we move on to find the value of VTH. for this circuit we have two loops. Let's call this as loop 1 and let's call this one as loop 2. Now this 42 volts drives current this way in the clockwise direction, that is considering the conventional flow of current method. Now let's call this current I, this as current I. So the current I produced by the 42 volts is the same current that flows through the 12 ohm resistor and the 6 ohm resistor. Now because we have an open circuit here and no current will flow in this direction, the current that flows through the 12 ohm resistor will flow through the 6 ohm resistor and return to the negative terminal of the voltage source. Therefore, we can find the value of I produced by the 42 volts. Now since the current that is the same current flows through these two resistors, it means that they are connected in series. Therefore, we have I to be equal to V divided by RT. We have the value of V to be 42, so 42 divided by V, we are going to add these two values, 12 plus 6 which is equal to 18, and this is equal to 21 by 9. So we have the current I to be 21 by 9 amperes. Since we have the value of I, we can generate an expression for VTH and find the value of VTH. So to find this value, we are going to use the second loop. Now let's choose any arbitrary direction for VTH. So we are going to move in the anti-clockwise direction, still considering the second loop and then taking the anti-clockwise direction for the 35 volt voltage source. Then we say that 35 plus VTH, because VTH is also in the same direction as that of the 35 volts. They are all directed anti-clockwise. So we have 35 plus VTH equals the sum of the voltages dropped across the loop. So we have I times 6 also moving in the anti-clockwise direction. So that is equal to 6 times I. Now since we want to find the value of VTH, we are going to transpose 35 to the right hand to the right hand side. So this becomes 6I minus 35. We know the value of I to be 21 by 9, that is 6 times 21 by 9 minus 35. 3 goes into 6 2 times, 3 goes into 9 3 times. We have 2 times 21 which is 42. 42 divided by 3 is 14. So we have 14 minus 5 and that is equal to minus 21. Therefore, we have VTH to be minus 21 volt. Next, we are going to find the value of RTH. Let's redraw the circuit by deactivating all the independent sources. Since we have voltage sources, we are going to short circuit them. We have the 42 volt being short circuited, and we have this to be the 12 ohm resistor, the 6 ohm resistor, and we have this terminal AB, and the 35 volt is also short circuited. And then we want to find the value of RTH, that is the equivalent resistance. This equivalent resistance is seen between the two terminals A and B. Now as we said previously that when you go through a loop without passing through any other circuit element except two resistors, then it means that the two resistors are connected in parallel. So we see this case here where we go through this loop without passing through any other circuit element except these two resistors. Therefore we say that these two resistors are connected in parallel. Therefore RTH is equal to 12 parallel to 6, and this is equal to 12 times 6 divided by 12 plus 6. 12 times 6 is 72, 12 plus 6 is 18, so 72 divided by 18 is equal to 4. Therefore we have RTH to be 4 ohms. Now since we have the value of VTH and then RTH, let's find the value of the current flowing through the 3 ohm resistor. So for the Thevenin's equivalent circuit, we have VTH to be minus 21 volts connected in series with RTH, which was found to be 4 ohms. And then since we want to find the current flowing through the 3 ohm resistor, we are going to connect the 3 ohm resistor between the two terminals A and B. That is, the load resistance is 3 ohms. Now VTH is going to drive current, say I, through the circuit, and if you want to find the current flowing through the load resistor, which is the 3 ohm resistor, and that will be equal to VTH divided by that is RTH plus R1. Now the reason why we are going to add these two resistors are connected in series. We have VTH to be minus 21 divided by RTH 4 plus RL 3. This becomes minus 21 divided by 7. Therefore we say that the current flowing through the 3 ohm resistor is equal to minus 3 amperes. So we have found the solution to this problem. Now let us take the next example. For the previous example, we had two voltage sources, and in this example we have one voltage source and one current source. Now let's find the current flowing through the 4 ohm resistor using Thevenin's theorem. The first thing we need to do is to remove the 4 ohm resistor, that is the resistor through which we want to find the current flowing through, marking the terminals and finding VTH. After drawing this circuit, let us consider this particular loop now. So consider this loop now. For this loop we have an independent current source. What this is going to do is, this independent current source is to flow in the anticlockwise direction, circulating in this loop over and over. So we have the 2 amperes currents flowing through the 5 ohm resistor in the anticlockwise direction. Let's move ahead and consider this particular loop. So for this loop, this 24 volt source is going to drive current in the anticlockwise direction through this loop. So considering the conventional flow of current, we have current moving in this direction, that is the anticlockwise direction, through these 3 resistors and then returning to the negative terminal of this voltage source. Now let's call the current driven by this voltage source to be I. What this primarily means is that we have I flowing through the 10 ohm resistor, the 5 ohm resistor, and at this point the total current that flows through the 5 ohm resistor is the value of I. I minus the 2 amperes current flowing through the 5 ohm resistor in the anticlockwise direction. So the total current flowing through the 5 ohm resistor is I minus 2. We have no current flowing through this branch because this is an open circuit. So all the current would flow through this direction and then return to the negative terminal of the voltage source. At this point we can find the value of I. So considering this loop, we have the voltage source which is 20 volts equals the sum of the voltages dropped across the loop. We have 10 times I plus 5 times I, and then here we have 5 times into brackets I minus 2, that is plus 5 into bracket I minus 2. Let's move on as we have to find the value of I. We have 20 equals 15I plus we distribute 5 across, we have 5I minus 10. So we add these two and then we have 20I. Now we transpose minus 10 to the left hand side, this becomes 30, and then we divide through by 20, and then we have the value of I to be equal to 3 by 2, which is 1.5 amperes. So this is the value of I, the current driven by the 20 volt source. Now from this we can find the value of V Thevenin. We can look through the terminal along this direction, and we can also view it from that direction. Whichever position you choose, you are going to arrive at the same answer. So let's consider this particular loop. We have VTH equals 5 times I, because we have I flowing through this 5 ohm resistor, that is 5I, and then we are moving in the anti-clockwise direction. This is also in the anti-clockwise direction, so it remains addition, plus 5 times I minus 2. Let's simplify this. We have 5I plus 5I minus 10. 5I plus 5I is 10I, so we have 10, and then we found the value of I to be 1.5. Therefore we have 10 times 1.5 minus 10, and this equal to 15 minus 10, and we have the value of VTH to be 5 volt. Therefore VTH is equal to 5 volt. Now let us find the value of RTH. From this circuit we are going to replace the current source with an open circuit, and then short circuit the voltage source. This becomes the 5 ohm resistor. We have also this 5 ohm resistor, and we have this to be the terminal AB. We have this 10 ohm resistor, and then we shall short circuit the voltage source. So we have this 5 and then 5, assuming that we have a voltage source here. Then at this point we have the current going to divide. We have part of the current flowing through this direction and the other part also flowing through that direction. The current that flows through this direction, that is through 5 ohm resistor, will be the current flowing through this 5 ohm resistor will be the same current that flows through this 5 ohm resistor, which clearly means that these two resistors are connected in series and their combination is connected in parallel with this 10 ohm resistor. Therefore we have RTH to be equal to 5 plus 5, that is for the two series resistors in parallel with the 10 ohm resistor. So this becomes 10 parallel 10. When two resistors of the same value are parallel to each other, then the resultant is half their value. So 10 parallel 10 is equal to 5. We have RTH to be equal to 5. If you have 10 times divided by 10 plus 10, 10 times 10 is 100 divided by 20, and it is 5. So we have RTH to be 5 ohms. Now let's find the value of current flowing through the 4 ohm resistor by assuming we have this to be our Thevenin's equivalent circuit. We have this VTH which is 5 volt, we have RTH which is 5 ohms, and then we have the load resistor which is 4 ohms connected in series with RTH. To find the value of the current flowing through the 4 ohm resistor, we have I 4 ohms is equal to VTH, which is 5 divided by RTH plus R1. So that is 5 by 9 amperes. Now 5 by 9 is equal to 0.556 amperes. So this is the current that flows through the 4 ohm resistor. I think this video gives a clear idea on Thevenin's theorem. Thank you.